Now, in this topic, we're going to be talking about electric fields. And today we're going to be specifically talking about radial fields. And these arise from point charges. Now, when we looked at gravitational fields, we looked at the equations and concepts due to point masses. And some of the concepts in electric fields are going to be very, very similar to what we looked at in gravitational fields. First, let's look at something called Coulomb's law, and this is almost identical to Newton's law of gravitation, except this is for electric fields and that was for gravitational fields. First, let's look at what the field lines look around the positive charge and a negative charge. Around a positive charge, the field lines point away from the positive charge. And around a negative charge, the field lines point towards the negative charge. Now, what Coulomb found out is that the force between the charges, whether they're positive or negative, or both positive or both negative, is proportional to the product of the two charges and is inversely proportional to 1 over the distance squared between their centers. So in this case, it will be this distance r. And this is exactly identical to Newton's law of gravitation, but instead of masses, we have charges. So we could therefore say that the force is directly proportional to the product of two charges over the distance squared. And we can change any proportional sign into an equal sign by simply adding a constant. And for Coulomb's law, the constant is equal to 1 over 4 pi epsilon naught, where epsilon naught is the permittivity of free space. And the value of k, which is equal to 1 over 4 pi epsilon naught, is roughly equal to 8.99 times 10 to the 9. And the value for your epsilon naught, your permittivity of free space, is given in your data booklets. So this here is your electric force equation. Now let's talk about something called the electric field strength. Now this is exactly the same as what the gravitational field strength is, but for electric fields. The electric field strength is the force per unit positive charge. So your electric field strength E is equal to F over Q, which is therefore equal to KQ over R squared. So your electric field strength equation is equal to KQ over R squared, where K is your 1 over 4 pi epsilon naught. And there are two units that you can use for your electric field strength, but the one that is more relevant in this case is going to be newtons per coulomb. So what does the electric field strength look like between two opposite charges that are nearby to each other? So we can draw on these arrows here. And since like charges attract each other, the electric field lines connect at the points that are nearby to the point charges. And they point in the direction towards the negative charge. Now for two like charges such as two positive charges, we know that these charges will repel each other. So the electric field lines at the points near the charge look something like this. You can see that these charges kind of push away from each other as they get closer. And there's like a little line in the middle here between them. The electric field lines from one charge will not cross that line and meet the electric fields from the other charge. And this is the same for a negative charge, except for a negative charge, the arrows point inwards. Now, just like with gravity, we also have an electric potential. And the electric potential is the work done per unit positive charge to move it from infinity to a point. And the electric potential has the exact same form as it does for electric fields as it did for gravitational fields, so you'll expect it to be minus kq over r. And it is also equal to the work done per unit charge. So with this kind of logic, you can see that the work done equation for electric fields is equal to kqq over r. And the difference in electric potential between 2 points can be known as the potential difference. And therefore this means that your electric potential has a customary unit of volts. Now, the best piece of advice I can give you after watching that video is to go off and practice some past papers or topic questions. These are single-handedly the best way to help you commit the content you've learned to memory. Obviously, go and do all the YouTube stuff of liking, subscribing, and if you found this video helpful, feel free to go and watch any of my other ones.